Welcome to the Crazy Hat Chemist. Here we go today on stoichiometry problems yet again. It's the sixth example here today on basic stoichiometry problems. So let's get moving. Bam! Okay, what is the mass in grams of 2.6 times 10 to the 20 atoms of plumbic chromate? So the first thing that we need to do is we need to get the formula, the correct formula for plumbic chromate. Plumbic is lead, and that's a 4+ charge. Chromate is CrO4 with a 2-. And there's both of those right there. You're going to take that 4, you're going to take that 2. You're going to take the absolute value of those numbers, flip them, bring them down, and then you have to reduce them. So your final formula is going to be PB parentheses CrO4 with a 2 outside. Okay? All right, fantastic. Hopefully that worked for you. Now, this is our flow chart that we have. What are we starting off with? We are starting off with atoms. Where are we going? We are going to mass. There is no direct route from atoms to mass, just like there has never been a direct route. You always have to take baby steps, one step at a time. So we're going to go from atoms to molecules. In going from atoms to molecules, it's always a counting number of atoms and one molecule that you're using. So one molecule of plumbic chromate has how many counted atoms? And there's going to be 1 of the lead, there's going to be 2 of the chromiums, and then there's going to be 8 of the oxygen. So 8, 9, 10, 11 atoms total. Okay? Now I have 11 atoms for every 1 molecule. Now I have molecules. Now I'm going to go from molecules to moles. And the number in front of the molecules is going to be Avogadro's number here. And then the number in front of the mole is always a 1, because that's what's in that rectangular box. That's kind of like a mole island. And then from moles, with 1 mole, I'm going to go to the mass. And the mass is going to be the molar mass of plumbic chromate. So I'm going to have to look at my periodic table, okay, get the molar mass for plumbic chromate. So now what I want you to do is pause the video really quickly. I want you to get the molar mass for plumbic chromate. Make sure you got the correct formula for it. I want you to write out the monorail and make sure you get it. And then we're going to unpause the video and keep on going, and this is what you should get. You should see that your atoms of plumbic chromate are going to cancel out, and it is 2.6 times 10 to the 20 atoms, and then 11 counting atoms. And then that's equal to 1 molecule in the numerator. Then our next term here, we have molecules in the denominator, and that's Avogadro's number, and then moles in the numerator. Then moles in the numerator are going to cancel out with moles in the denominator of the next term. And the molar mass of plumbic chromate is 439.2 grams per mole, and that has 1 decimal place because lead has to 1 decimal place on the periodic table of which we're using here. Okay, then we're going to take all these numbers and figure out how many significant figures we have. So 2.6 times 10 to the 20, that's 2 significant figures. There, in the 1 molecule has an infinite number of significant figures because this is a definition. That is, 1 molecule equals a counting number of atoms. But we're going to carry on with the rest of our numerator terms. 1 mole, that's infinite number of significant figures. The 439.2, that has 4 significant figures. Now I'm going to go back to the denominator where I have 11 atoms, and these 11 atoms you counted. And remember, it's either definitions or counting where you have an infinite number of significant figures. Avogadro's number here, we're using 4 significant figures, and then the mole value of 1, we have an infinite number of significant figures. We're going to take our calculator, get the correct answer that's in our calculator, that's what's in our calculator. This is multiplication division, so the fewest number of significant figures that I have on all the numbers is how I'm going to round this number. And it looks like there's 2 significant figures, so therefore I am rounding in the 3rd place there, which is that 2. That 2 is going to be truncated. Now, you don't want to truncate the entire number because you still have that times 10 to the 2 there, so you need to maintain that. So it's 1.7 times 10 to the negative 2 grams of plumbic chromate. And that is a number, units, and a formula, and you should always remember that. Okay? Hopefully that problem worked really well for you. I'm going to show you just a couple of little tricks on this problem here. So, same problem, same stoichiometric path and monorail that we had before, but we are going to use this one with a little bit of a kiss. So, kiss is something that I learned from one of my college professors, and she said Keep it simple, stupid. Remember to always give your problems a good kiss. And here's what we're going to do. You see that monorail that we have set out with everything down there? We have number, we have units, we have formula. One of the things that I've noticed with many of my students is that they have a difficult time getting the correct number after having that correct monorail set up. And really, 90% of the problem is already done with that correct monorail that's up there currently. So what we're going to do is we're going to get rid of some of the things that are on here so that we can do the right math in our calculator. And so what I've done is I've just maintained the numbers but gotten rid of the units and the formula. Okay? Hopefully that makes sense. Now I'm going to do one more thing. I don't need to multiply or divide by 1 because we know that the answer is what the number was prior to that. So I'm going to get rid of all the 1s as well. Now I have a really simple mathematical problem. I have things in the numerator, I have things in the denominator. A really simple rule here is if it's in the numerator, you multiply. So the 2.6 times 10 to the 20 times 439.2. And if it's in the denominator, you divide. So the 11 is in the denominator. You're going to divide by 11. The 6.022 times 10 to the 23rd is in the denominator. You are going to divide. And you can do this a variety of different ways. You can do 2.6 times 10 to the 20 divided by 11 divided by 6.022 times 10 to the 23rd times 439.2. You could start off with the 439.2 times 2.6 times 10 to the 20, then divide by 11, then divide by Avogadro's number. It doesn't matter, okay? But no matter how you do it, you should always get this same number, and that's 1.7 times 10 to the negative 2. That's the same answer that we got on the previous slide, okay? Now, I want to make a special note here for you. This method here does not count for showing your work. Showing your work is on the previous slide. So if you need to show your work, which all of my students need to show their work, you need to do what's on the previous slide. But if you need to keep it simple, stupid, so that you get the correct numeric value after you've set it up, then try this method, okay? It works all the time. What kind of assessments do you think chemistry students prefer? Multiple choice, of course. And, of course, there's a mole using a multiple choice. Couldn't ask for anything better. And that was the end of that video. I hope you have a great time and look forward to seeing the final video in this subset of basic stoichiometry problems. I'll see you next time.